Okay, lesson 21, the last lesson of the class. So big smile in this video, video 21A. We are going to look at two sample means in lesson 21. So in lesson 20, we compared one sample of data, summarized with a sample mean, to a fixed parameter value. And an example that we looked at was the tire tread example. We tested for evidence that the population mean tire tread was less than 50,000 miles. In the last example that you had with the fire sprinklers, we tested for evidence that the population mean time for a fire sprinkler to activate was under 30 seconds. And both of these were examples of one sample mean problems. We went out, we collected one sample, we compared that sample data to our hypothesized population mean values. In lesson 21, we are now going to compare two samples to each other. So some examples of this. What if we wanted to look at, do Ivy League students have a higher average IQ than, say, Cecil students? We'd be comparing two groups, Ivy League students, Cecil College students. Is there a difference in the mean weights between NCAA football players in Division I, one group, and Division III? Is there a statistically significant difference between husband and wife's emotional intelligence score? So you'd be, again, looking at two groups. And finally, can Cecil College students do better on a math placement test after attending a math boot camp for 1 week? So we might look at their test scores before the math boot camp, compare them to their scores after. So again, two sets of information. There are actually two different scenarios, and we had both of those in the previous examples here, that we're going to look at in lesson 21. Sometimes our samples will be independent of one another, and sometimes our samples will be dependent. So we're going to look at two scenarios, one where we have independent samples, and one where the samples are dependent. Sometimes we'll say they're paired. So independent samples, let's talk about the difference. With independent samples, the data collected in the first sample have no impact on the data collected in the second sample. So examples of independent samples, if we looked at Ivy League students versus Cecil College students and compared IQ scores, this group of students has nothing to do with this group of students. They are two independent sets of samples. If we looked at NCAA football player weights for some players from Division I versus some players from Division III, those two sets of data have nothing to do with one another. These weights don't affect the weights of the players in a totally different division there. They're independent. So these are examples of independent samples. With dependent samples, the data collected in the first sample is paired with the data collected in the second sample. So some examples. If we wanted to compare, emotional IQs for husbands and wives, we would look at pairs of data. We would look at the husband's score versus his wife's score. For the next couple, we'd look at the husband's score versus his wife's score, and we would have pairs of information. For the math placement test scores before and after taking a boot camp class, we would look at my score before I took the boot camp class, my score after, and compare that set of data. We wouldn't look at my score before the boot camp test and compare it to somebody else's score after. That'd be sort of silly. So we would look at pairs of information. So you have dependent samples if you have paired data. The methods for testing independent samples or dependent samples are quite different, and so it's going to be important that we know which scenario we're dealing with. And so when reading a hypothesis test problem, you sort of want to ask yourself a series of questions, and you want to ask yourself in this order. First thing, does this problem deal with means or proportions? Is your variable quantitative? Is your variable categorical? Once you've made that decision, are you looking at one sample or two samples? Then, if it's a mean problem and you have two samples, are those two samples independent or are they dependent? So that's sort of the sequence of questions that you want to ask yourself. Okay, let's go through the steps for a two-sample t-test. I'm going to look at the case where we have independent samples. We'll address dependent samples in a future video. So we've decided it's a mean problem. We have two samples, and our two samples are not paired in any way. One set of data has nothing to do with the other set. We have independent samples. How would we conduct a hypothesis test? So the first thing you do is you write your two hypotheses. And when we have two means, your null hypothesis, you'll be testing to see, is the mean from the first group, is it the same as the mean from the second group? The null hypothesis will always assume that those two are the same, and then we'll be looking for evidence that they're different or that one of them is bigger than the other one. So for your alternative, you might have that the mean of the first population is, say, bigger than the mean of the second population, or that could be a less than symbol there, or just are those two groups, do their means differ? So you'll have one of these. Again, just like in previous problems, you'll figure out what symbol goes there based on the context of the problem. What's the problem say? Okay, after we write down our hypotheses, the second thing we'll do, this hasn't changed, is check our conditions. And these should be pretty familiar for means. Since we're looking at a mean problem, you want to make sure that you're dealing with a quantitative variable. And we're comparing two means from two independent samples, is the example that we're going to look at today. And so both of your samples should be random. If they can't be random, then they should at least be unbiased. Both of our sample sizes should be less than 10% of their respective populations. So same assumption we had with testing one mean, only now we have two samples. And so both of our sample sizes should also be at least 30. Or if your sample sizes, if one or both of them are on the smaller side, then you want to find evidence that both of your populations are normal. And we saw how to do that in some previous videos there. You want to make sure that you check histograms and QQ plots for your two samples. You'll have two histograms to check and two QQ plots to check, one for both of your samples if your sample sizes end up being small. So those are our conditions. After our conditions, we're ready to conduct our test, so we need a test statistic. And just like when you had one mean, we computed a t-test statistic. We're going to compute a t-test statistic again, but the formula will be a bit different since we have two samples. We'll look at our two sample means, and we'll look at the difference of those. And then we'll divide that by a big square root here, where we take the standard deviation for the first sample. We're going to square that, divide by the sample size of the first group, and then we'll add that to the standard deviation of the second group. Again, that gets squared, and we divide by the sample size of the second sample there. The degrees of freedom formula for this test statistic is that the formula is a little bit complicated. So for the course workbook here, we're going to give you the degrees of freedom. In class, we might show you a shortcut that sort of sometimes works. But I'll say here that the degrees of freedom we're going to provide you with. And I'm sure we'll address this more in class. All right, then after you get your test statistic, just like before, based on the value of that test statistic, we'll draw a picture and figure out what the p-value is. So nothing's changed here, same thing. So run the test, got the test statistic, now let's get the p-value. Always helpful to draw yourself a picture. Remember, when you get your test statistic, t, wherever that might be, let's say it's over here. you're going to shade in the direction of your alternative hypothesis. HA. So if this had been a greater than test, we'd shade here. Let's just say, for example, that we're looking at a two-tailed test. We would shade here. We would come down here, plot our test statistic of the opposite sign, shade that tail as well, and the p-value would be the area of both of those tails put together. If we had a one-tailed test, it would just be the area of one of those. To get the area under the t-curve, you should be able to do that. Use the t-calculator on StatCrunch. You're getting the area under that t-curve. Once we have our p-value, that's what we're going to use to make our decision. So step 4, make your decision. If that p-value is small, we'll reject the null hypothesis in favor of the alternative. If the p-value is not small, we'll fail to reject the null hypothesis. We won't find evidence in favor of the alternative. And then regardless of your conclusion, whether you reject or fail to reject the null hypothesis, make sure that you write a concluding remark in the context of the problem. What did you find about IQ scores of Ivy League students versus Cecil College students, or whatever the problem might be? Okay, one little note here with regard to the hypotheses. We said that the null hypothesis was that mu1 equals mu2 versus that mu1 is greater than, less than, or not equal to mu2. It's okay if we'll typically write the hypotheses that way, but sometimes, rather than seeing it written this way, you might see the null hypothesis written as a difference of those two means. If these two are the same, then their difference is going to be 0. And same thing, we wrote the alternative, let's just pick a less than, this way. You might see that written as a difference. They mean the same thing. You do not have to write this set and that set of hypotheses. Just write one of them. They say the exact same thing. But sometimes you'll see them written that way. A two-sample t-test is a test for the difference of two population means. So difference means subtract. And so, that's why sometimes you'll see them written this way. In class, I think we'll tend to use the first approach. All right, so that was a comment about that. This video is just to go through the steps. The next couple of videos, you'll go through some examples on hypothesis testing to begin with independent samples. That's it for this one. Thanks.